The next thing we'll do is a little bit of a change in direction from what we've been doing so far. The idea is that we're talking about indexing and index portfolios. Let's look at this idea of a managed portfolio, its performance and risk, and we'll do so relative to an indexed portfolio. So managed portfolios are also called active portfolios, and an active portfolio can be compared to a benchmark. And the way we'll do this comparison is we'll look at the average deviation from the benchmark, we'll look at the tracking error, and we'll look at something called the information ratio. And we'll define all these things and we'll calculate all these things. And the idea is to assess if there is a benefit of active investing relative to passive benchmark investing. So first, let's talk a little bit about mutual funds and how they work. And we'll cover this in a lot more detail in Chapter 4, so it'll be a little quick and a little simplified now, but enough just to get us through this discussion. So mutual funds can either be active or passive. Active funds hire portfolio managers to pick stocks in an attempt to earn as high a rate of return as possible. Active funds charge a high management fee, often something called a 12B1 fee, and we'll talk about what those are later. But together, these two fees can be anywhere between 1% and 2.5%, and sometimes this is referred to as the expense ratio. And that means in every year, for every $100 you have invested in the fund, $2.50 is taken by the fund's managers to pay for a number of things, including marketing of the fund and producing all of the reports and documentation, but most importantly, hiring the people who are attempting to pick the best stocks. Some active funds also charge a commission to buy the fund, and this is called a front-end load. And front-end loads average around 5%. And so for every $100 committed by the investor, only $95 is invested in the fund, and $5 is paid to the broker or brokerage site that sold you the fund. And so therefore, since only $95 goes in, an extra 5.26% to go from 95 back to that 100 must be earned by the fund just to cover this front-end load. Passive funds, which are also called index funds, hold only the stocks necessary to track an index. And index examples include, well, an index of all stocks, or small, mid, or large cap, or value, blend, or growth, and sometimes combinations of this, so it could be small value or large growth. Sector funds or industry funds, sectors larger than an industry. They could be geographic. They could be economic development categories, emerging markets, or industrialized. There's lots and lots and lots of different indices, and people have created funds to track many of these indices. Passive funds, therefore, don't have to hire people to choose the best stocks, and so they charge very low management fees. And so total passive fund fees are usually less than 25 basis points and often as low as 10 basis points. And passive funds don't charge front-end loads. Okay, so here's the idea. Active funds are assigned a benchmark index based on the declared investment categories. And an active fund's performance then can be compared to this benchmark index. The idea is that I could invest in the active fund, or I could invest using some other vehicle to invest in this passive benchmark index. Let's compare the two. And the way we're going to compare the two alternative investments, active versus passive, is to calculate the average deviation, the tracking error, and the information ratio for these pairs of returns. And so we're going to use this to compare an active managed portfolio to a benchmark index. And the theory is that for an active portfolio with similar risk to some benchmark, an investor could invest in the benchmark as a cheaper alternative to the active. And so in addition to the total risk of the active, we can also measure the active portfolio's risk as deviations from the benchmark. And so here's the idea, is that the alternative investment to the active is this passive benchmark, and so we measure not the total risk of the active, which we could easily do, and we will do, but in addition to that, we measure the risk relative to the benchmark. And we'll see why this is important in a minute. So here are our three computations. The first is the average deviation, and it is the historic return of the active portfolio relative to the historic return of the benchmark in each period. We'll do 60 months again, and then you divide by the number of months, and this gives you, well, essentially how well did the active do relative to the passive, how well did the active do relative to the benchmark, and in theory, this could be our expectation going forward. So the average historic deviation of the active relative to the passive, the active portfolio relative to the benchmark, might be how much we expect the active to beat the benchmark or not beat the benchmark going forward. The next thing we want to talk about is variation between the active and the benchmark. How closely did they track? Were they right with each other, or were they all over the place and different? And to do that, we're going to compute something called the tracking error. And so the tracking error is the return of the active portfolio minus the return of the passive benchmark. And just like the standard deviation, we'll square that so that positives and negatives don't cancel each other out. We'll sum them. We'll divide by n minus 1 because we just have a sample of these deviations. And then we'll take the square root because this is returns minus returns is returns squared. Sum divided by n minus 1 is still returns squared. We take the square root to get us back to returns again, so we can compare this average deviation, which is what we expect the fund to do relative to the passive benchmark. We can compare that to the degree to which it varies from the passive benchmark. And let me just draw something really quick to give you an indication of what we're talking about. So here's the idea. Over some period of time, I have a set of returns, and I'm going to draw the return for my benchmark, and I'm also going to draw the return for the active portfolio. And in this case, I've drawn it in such a way that the active portfolio consistently beats the benchmark by a stable amount. And in this situation, I'm also going to draw the benchmark, and I'll draw the exact same benchmark. At least that's the idea. But now I'm going to show an active portfolio that's sort of all over the place. And I've tried to draw this in such a way that the net amount by which the active beats the benchmark is the same, but it's obviously more consistent in the drawing on the left. And so the idea is that the average deviations for both of these active portfolios are the same, but the tracking errors are completely different. And the idea is that even though both of these are going to have the same expected deviation going forward, both of the blue lines relative to the green lines, here, given the difference in the tracking errors, we can make some sort of assessment about how likely it is. This portfolio, given its track record, is very likely to beat. This portfolio on the left is very likely to beat the benchmark because it's consistently done so. This portfolio is less likely to do so because of how volatile it is relative to the benchmark. So we have an idea of what the average deviation measures. We have an idea of what the tracking error measures. Just to compare the tracking error to the standard deviation, the tracking error is a squared deviation from the benchmark, whereas the standard deviation is the squared deviation from the mean. And the same way we use the standard deviation to make estimates and confidence intervals about the expectation of the return of the active portfolio going forward, we can use the tracking error to make calculations and estimates about some confidence interval of the active portfolio relative to the benchmark. So again, the standard deviation is the sum of the squared deviations from the portfolio's mean return, and the tracking error is the sum of the squared deviations from the benchmark. Note that the units are the same in both, meaning this is returns squared and then square root, so this is just returns again, and the same thing here. And so my average deviation is going to be in return, and my tracking error is in return. And so therefore, I can compute the information ratio, because I have the same units, as the average deviation relative to the tracking error. And this is going to give me a relative size of how much I expect the active to beat the passive, divided by how volatile the active has been relative to the passive. So how do we interpret these? How do we interpret the average deviation, the tracking error, and the information ratio? Well, the average deviation is the expected amount by which the managed portfolio will beat the benchmark. The tracking error is essentially the standard deviation of the beat, which means the information ratio, which is the ratio of these two, is the expected beat divided by the standard deviation of the beat. It's kind of like this z value again for mu equal to 0. Because remember, what I'm really concerned about is the managed beating the benchmark. And so I can compute the expected beat divided by the deviation of the beat. If x is 0, then it's whether there is a positive average deviation. So we can interpret it kind of like the z for x equals 0, the size of the beat in the number of standard deviations of the beat. And we can use it to estimate the likelihood that the beat will be positive or greater than some number, such as the amount necessary to cover a front-end load. So let me go to this spreadsheet example, and we can look at some actual calculated numbers.